Hello. Welcome everyone. Good morning, good afternoon, depending where you are on the planet. Today we are going to join ourselves on this webinar. It's presented by Project Smart Explorer and by to-recylcing, as always. Thank you very much for coming to today's webinar. I would say the context is a little bit specific. We'll talk in a minute about it, but today's webinar is really focusing on new application, waste to recycling, biofuel, and SAF. SAF stands for Sustainable Aviation Fuel. And today we're going to talk about the technology behind those projects, but also the market outlook of those projects. If we are proposing you today those type of projects, this is because we think those projects are now taking off a little bit. Since mid of last year, we saw those projects getting on a little bit. And what can be interesting is, of course, to discuss the detail of it with you. Today, it's more, let's say, an informative talk, but of course, we'll see some business prospection later on. So from these, just a point I would like to carry on, but I will repeat it at the end. From the conversation today, you have some link. Today, you can ask us the slide of today's webinar directly via email at Guilhem Jean at to-recylcing. You can follow us on LinkedIn to get the invitation of our next webinar, because our next webinar will be more into, I would say, the daily business, because on April 13th, we will talk about the Ukrainian crisis. What are the impact on the oil and gas business in terms of project? I will not discuss, I would say, the political aspect of it, etc., etc. This is not our expertise. We'll mostly focus on the threat for our business, but not only the threat, but also the opportunities, because a lot of things are happening there. And there will be a lot of things to say, because it's quite interesting how you can reposition yourself from this business, and of course how much business it will create in other regions of the world. So if you are interested by this Ukraine impact on our business, I invite you to go into the conversation of today's webinar. And normally I already published the link to access and to download your invitation for this webinar. So this is a little bit the announcement for next event. What is still interesting is on today, waste and biofuels, SAF, etc. I'm going to present a lot at the beginning. Of course, as always, we will take time at the end to answer all your questions, but do not hesitate during the webinar to ask your question directly in the feed. We will address all of them at the end. So the agenda today is pretty clear, if I may say. First, we'll talk about Project Smart Explorer, okay, where we stand, and of course, what type of application we'll discuss today. Then we'll discuss about the need and the trend of those applications. We'll go on the technology, and then after those two aspects, we'll go more to the business, let's say, prospect. Today, market, the 5-year outlook that we have in Project Smart Explorer, and then we'll try to give you some trends for 2013 and 2050 market outlook. So, as you know, and I guess most of you know us very well already, you know Jean-Charles, you know myself. Jean-Charles has been a VP in ABB, he was in charge of all the oil and gas business. And myself, I was a more Siemens guy, also in the oil and gas business. And we have a tool called Project Smart Explorer, where we trace all the oil and gas projects, not only oil and gas, because today we're going to talk a little bit more about energy transition, but just to enable you, we still have this focus. And today, last few weeks, we have just celebrated our 10th birthday, just to give you that. And many of you have received the notification, and we're really happy about it. So thank you very much, and thank you for those 10 years working together. Today, from the scope of 1,000 projects, we are going to look a tiny part of it, which is really interesting because it's one of the most dynamic ones as of today. Into energy transition, we have already spoke about two aspects. We already made a webinar about hydrogen. We already made a webinar about carbon capture, which were the two, let's say, biggest trend into this energy transition. But today, we are going to focus not on renewables, which is a big part of the database as well, but more into the decarbonification, and mostly the two aspects you see here on the right of the slide, the recycling, so all the waste to energy, plastic, chemical, hydrogen, and so all what we call bioenergy, and into those you will see the biogas, the biofuel, and the sustainable aviation fuel. So today we are really going to focus on those applications, even if it's a small fraction of the market today. It has really a big dynamic, as I was saying, and it's quite interesting to check as of today how it's moving, and of course what is behind the drivers, etc., etc. And we'll try to today together to understand what are those trends. So the need and the train of those applications, I will always try to go in this order: waste to recycling, biofuel, and SAF. Biofuel and SAF will mostly be associated because behind it's more or less the same business and the same application. But okay, we will go in detail case by case if we need to. If we look, let's say, from the broader view, from the global perspective, what is happening today in the world, and mostly in the world of energy, today the challenge of the energy transition is, if we look at the broader picture, not to go into renewables, not to go into decarbonification for the sake of it. The idea is to reduce the annual global greenhouse gas emission, okay, which are responsible for the climate change. This is a broader picture. Here I put you an extract from the report of the GIEC from this year, where they are trying to make the scenarios to say, okay, depending on this amount of gas emission and greenhouse gas emission, we will live in a world where the average temperature has gone plus 2 degrees, plus 4, minus, etc., etc. So of course you see here different scenarios, and the effect behind and the pressure we have as of today on oil and gas, not only oil and gas users, but also on the oil and gas producers, is to say, okay, we need to reduce this global greenhouse emission. Of course, the oil and gas industry is one of the first, I would say, on the front line to tackle this problem, because it's somewhere responsible for the production of CO2, but also to the production of product which later will produce CO2, even if it's by the means of many users and many layers of our industry. Yet it means that today the pressure is on oil and gas companies and our businesses to reduce this greenhouse emission, okay, by any means. But today the problematic we have, and that's why it's a big challenge, is that there is no real vector of energy that we can completely switch from one another, okay? Even if many people would expect or believe it's possible to close all the tap of oil and gas worldwide and to stop emitting this way, we see today, mostly in Europe, just by the discussion we have on gas with Russia, that it's not so possible to do from one day to another, to switch from one energy to another. And of course, today we're in the situation where we have to reduce those greenhouse emissions, yet there is no vector of energy available to replace oil and gas. So one of, let's say, the issue of, not issue, but one of the solution of this challenge is to say, okay, as we cannot make, let's say, a quick transition to new energy, green, etc., etc., the idea is to continue to use fossil. Okay, reduce this usage if you can, but to continue to use those fossil energy, but in a cleaner way. So for this, we have discussed already about hydrogen, we have discussed also about carbon captures, and today we are going to discuss about waste to recycling and biofuel, because that's another way to do that, exactly, to carry on to use those fossil energy that we know how to use, we master, etc., but to do it in a cleaner way. And why, and what is the idea behind this idea of waste to recycling and biofuel? The idea and the main concept behind is to close the carbon life cycle. On the left of this slide, I try to kind of picture a little bit the carbon life cycle that we have as of today, which is in blue, meaning that we start from natural resources, which are inside our planet, can be under the form of wood, of gas, of coal, of oil, and we are going to extract this energy and this carbon from our natural resources. We are going from this extract to process this energy, to transport it, at one point to use, of course, this energy, but the whole mean of it, and then it will go either into CO2 into the atmosphere, or we will have a part of this carbon which will be remain as disposal, okay, in the trash or in many other formats, etc., etc. And the idea behind is not to stop the carbon loop here as we are today. The idea is to close this loop to have kind of a circular economy. Okay, I know it's a trendy word, but that's a little bit the concept behind, to say, okay, we are going to close the loop and the life cycle of the carbon to make sure that we are always using the same carbon and we are not releasing more carbon than what we are doing actually. And that's where those applications of waste to recycling, biofuel, and SAF are starting to exist and have been created in some ways. The idea is to build this missing step between the disposal and the energy extraction. Because even if we have used those fuel, there's still carbon in it, there's still value in it, and the change is to say, okay, let's reuse them to make sure that we can extract or reuse them to produce more energy. So that's a little bit the idea. And if we look from the carbon picture and the carbon footprint, closing this loop is going to create an effect which is called the displacement of the carbon footprint. Because of course, if you are going to source energy extraction from those raw material, you are going to, let's say, take into account the carbon footprint you have avoided at this step, but you are also creating at this one. In more detail, I've got this slide to explain it with a really easy example. In this case, we are going to talk about the wood and the carbon footprint of wood, okay, as it is. If we stay, we took the wood because it's the simplest one, but it will be the same example and the same logic for all the piece of material you can use to source and feedstock those applications. Imagine you have wood, okay? You may have wood inside your house, but most of the wood today as a trash or as a waste we have is going to decompose into the air, etc., etc. So what is really interesting is to say that the wood decomposition, it's a long process, but today this decomposition will create two things: methane, which will be released into the atmosphere, and it's going to create solid carbon, which will stay more or less in the ground. So what can be interesting is to say, okay, today, this is the main, let's say, path for wood to disappear and to be wasted and recycled in one way. But the carbon footprint of this, let's say, process is huge because, as we all know, methane is a huge, which is that guilty gas for global warming. So the idea is to replace this decomposition with two possible ways. Either you are going to use this wood as biofuel and SAF. You are going to use the carbonate, the carbon which is stored in this wood to create biofuel. And when you are going to use this biofuel, of course, the fuel is going to release CO2 when burnt. But the compensation is that all the energy you would have spent here to create this biofuel will not impact as badly the atmosphere under the CO2 emission than what it would have been under methane. In the same way, you can burn this wood straight away without any transformation to produce energy. So first, you are going to use energy from those waste. And the second advantage is that you are going to release into the atmosphere CO2. And once again, this CO2 is way less harmful than what methane is. In average, if you compare CO2 emission from burning the wood to the decomposition of the wood, the carbon footprint of the decomposition, is 25 times larger than the one of the burning. So it means that by taking wood, not leaving it, let's say, in the trash, etc., but just by burning it, you are going to decrease your carbon footprint. And one way to make your calculation about the carbon footprint, and that's, let's say, the trick about all those applications to waste, recycling, and biofuels, is to avoid one carbon footprint to the benefit of a less harmful one. Okay, of course, here we are not saying that making waste to energy by burning wood is, of course, eco-friendly, etc., but burning this wood is less harmful than just leaving this wood decomposite and deteriorate in the open air. So the calculation behind is to say, okay, the total footprint of my waste to energy or my biofuel is the burn footprint that you're going to have from either your wood burning or your fuel burning, minus the footprint of your decomposition. And in this case, it's quite easy to have a situation where the total footprint of your operation, of your recycling of wood, is going to have a negative footprint. which means that in some cases, and that's the case for mainly for the SAF, that reusing those waste is going to generate plants which are called carbon negative. Even if those plants are emitting a lot of CO2, they are, let's say, replacing a situation where it would have been emission of more harmful gases. So it means that by creating those plants, by sourcing feedstock, etc., globally on the planet and life cycle of carbon, you are going to have a more better impact or a less harmful impact than what it could have been. And that's a little bit the trick behind. So now the reason of this trend and those applications is that they have many advantages. The first advantage is that when you are going to use, let's say, biofuel, you are going to use SAF, or you are going to recycle plastic, etc., you are not going to need to adapt all your industry or all your users to a need of new energy. That's not the case. For example, if you turn from fuel to hydrogen, or if you turn from fuel to green electricity. Here, no adaptation is needed because the end product and the output product is exactly the same. Of course, the idea of this closing this carbon cycle is quite virtuous, and we can all understand why, because we are able, let's say, to reuse our energy in an unlimited basis. Of course, it's not totally true, but kind of. Then the third aspect, which is today one of the most important, is that by using those applications, you can have a neutral carbon footprint on your application and your usage of fossil energy. And you can even have, in some cases, a negative carbon footprint, which is even more interesting. Then if we go more to, let's say, execution detail, the chemical processes behind are well known. They are masters. Okay, we have worked with those in the chemical industry for ages, if I may say. Those applications are quick to deploy. If we compare that, for example, to green hydrogen, where we are trying to scale up a little bit our know-how, etc., here we are talking about processes where we have more maturity and where all the equipment is already available. What is also interesting is to see that those applications, if you see the barrel price getting high and the price of gas or plastic getting really high, as we are in the situation today, those recycling and biofuel are becoming cost competitive. Okay, so that's also one of the enablers to say, okay, as we're starting to not lake raw material, but we're in a situation where this raw material is expensive, recycling is starting to become more cost competitive. And of course, the last idea, but which is also virtuous, is to say you can create value from waste, which today was a burden and a problematic for many of our societies. The idea by recycling them is to say, okay, we're going to create value and create business from that and clean a little bit our way to use. Behind, of course, and that's again the big picture, but it explains the opportunity behind. It has huge opportunities and huge business possibilities, because with that you can create zero emission plane with a sustainable aviation fuel. So it's a huge marketing advantage. You can do the same with carbon negative cars, because if you source and you fuel your car just with biofuel, it means that using your car will diminish the carbon footprint of the world. So it's also quite a huge competitive advantage to say. And of course, you can reduce the carbon footprint of many processes, like in the refining, if you have a beer refinery, etc., etc. And the last part is that you can start to generate profit from recycling. So that's also a big topic, because companies, as soon as they are able to make profit from some processes, they will be happy to enter them. So that's a little bit all for the need and the trend. Of course, the need is to, let's say, save the planet and save our environment. And the trend is coming from this effect of negative carbon footprint on the global picture, but also as it's becoming quite competitive to have those applications as feedstock for raw material. So now if we look more into the technologies, and here I'll break down a little bit more per application. It's interesting to see, and coming from, if you come from the oil and gas industry, you have to see those applications a little bit like downstream, okay? Meaning that it's not an extraction of carbon from the ground, okay, as we have in the oil and gas. It's more the transformation of carbon, which is already there, okay? So it means that you will not have, let's say, what we call the production and all this upstream part in this supply chain, meaning that you will never see a waste to recycling or biofuel or SAF being offshore, okay, in the middle of nowhere. Usually, those projects will be located close to the users or close to the feedstock that will be used to run those processes. What is also interesting is that those products will be replacing a little bit, let's say, the crude oil or the gas produced, as we may have, as a feedstock for then refining product for crackers, etc., etc. And these feedstocks may happen everywhere a little bit, because when you think where do you have plastic waste, where do you have bio waste, etc., etc., it can be really everywhere. And the idea is to deliver those feedstock to the location where we have those plants, or to create a multitude of those applications. What is also interesting is that the idea of those projects is to produce directly the final product, meaning that in most of the cases, those plants are going to integrate all the process, meaning that if you take, just as a random example, banana peels at the entrance, you won't have banana peel and then somewhere the process will stop at the naphtha, etc., etc. No, the output of this plant will be the end product, meaning it will be jet fuel, it will be biodiesel, it will be bioethanol, etc., etc. But you won't have, let's say, two steps or two processes in the same way. You will have really starting from the feedstock and the raw feedstock that you have collected as a waste until the end product that will be directly used as an energy vector. So of course, if we look at those applications, it's a process industry like we are used to. It's also a project business. Okay, we have more or less the same organization with operators, engineering company, EPCs as well, contract are getting signed, etc., etc. So if you are comfortable into the oil and gas and energy business, you will feel comfortable in this business, especially since the processes are close to the petrochem activities that we have as of today. What is also interesting that in those projects, they are not closed door, meaning that you don't have one which is going to be only producing SAF, for example. Most of the time, we see a variety of production in those projects, meaning one will make bioethanol, hydrogen, SAF, biodiesel, etc., etc. So you will have different variabilities, but that's something that you are really used to if you are working in the petrochem business, where you may have different output from the same feedstock. And that's why we put this slide at the beginning of the technology which we're going to be used and the process which we're going to be used depend on the feedstock itself. Because of course, if you have banana peels, it's not the same if your feedstock is plastic or domestic waste, etc., etc. So that's what will be our key of entry to go see our application. The first one is to say, okay, if we have waste which are polymers, what are the process, what are we talking about, etc., etc. In this case, and under polymer, we are talking about all the plastic you will find around the world. It can be PET, it can be polyethylene, polypropylene, etc., etc. And here on the graph on the left, you see a little bit the waste polymer flow that Europe is trying to build to the horizon 2030. So it's in million ton metric. I will not go in the detail of the figures. You have the slide if you're interested in, but on the left, you have the liquid feedstock of polymer that we have as of today on the market. And here, what you see, the loop on the top are the recycling and the waste to recycling element that would be part of this industry. What is already quite interesting is to see that almost half of the raw material will come at one point from recycling or will be used as or will be recycled at one point in its life cycle, which is totally different from today, where about only 5 to 10% of those polymers are recycled. The objective is really to grow there, not only because it's good for the planet, but also because it creates a lot of value. So from there, you have different ways to, of course, to recycle and create value from those waste of plastic. The first one is, let's say, to make waste to plastic or waste to chemical. In this way, you have two processes that can be put in parallel. The one which is the most well-known, if I may say, and which is the one implemented today, but which will grow in the future, is the mechanical recycling. The idea in this way is to you collect your waste either at the production site, either after it has been used. And if you are in Europe, for example, you have a trash where you can put all your plastic. This plastic goes to those locations for mechanical recycling, meaning this plastic is grinded, cut in small pieces, and then it's going to be breaking down into small granulate, which is small balls at the size of about half an inch or 1 centimeter, more or less. And this granulate will be used as raw material, meaning it will be melted and then reused again as plastic, or it will be melted to make different layers of chemicals and will be used as naphtha. In few cases. The second type of recycling, and that's one which is developing quite quickly, is more, let's say, chemical separation called the monomer recycling. In this case, the plastic will be collected, it will be broken down and heated to high temperature. And in this way, with additives, the chemical separation of all my material will break down all the product into plastic molecules, and then this plastic molecule will be transformed by different chemical processes to naphtha. It's looking a little bit like a cracker, if you are familiar with that. And the idea with this recycling is to go back to naphtha, and of course from naphtha, then you can produce many type of application. You can produce ethylene, but you can produce aromatics, etc., etc. So here you can have a broad portfolio of product. And then the second, I would say, big categories to reuse those waste to polymer are the waste to energy. In this case, it's not so much about recycling. The idea is to produce energy. Either you are going to burn your plastic at really high temperature into a pyrolysis process, and there you are going to generate electricity and some, let's say, solid carbon, hard carbon, or you are going to, and that's mostly the case of project which we can see at the municipality level, you are going to incinerate your plastic, and there you are going to generate heat for local organization or local domestical usage, etc., etc. So you see that from plastic and the waste plastic, you can have two broad processes. Either you are going to recycle it, which is a way to close this loop. Either you are going to reuse this carbon as an energy mean to produce energy. And there, of course, the compensation of your footprint to reuse will, of course, be lower than the footprint it would have been if you just trash your plastic into the sea, into the ocean, etc., etc. If we go not to the plastic waste, but to the domestical waste, so here, just to make the difference, plastic waste or polymer waste is the one that, okay, you filter, you put in your yellow trash if you are in France, but the domestical waste is more random, okay? It's in Europe, I think it's the gray trash in all the country, where you just pour everything. And in this case, okay, you have three possibilities. It's the same, more or less, process. It's always a process, a thermal process, if I may say, but with different, I would say, layers, and that's a little bit the graph I put you. You have three outputs there, which are quite interesting. The first one is, of course, the waste to energy, because if you burn it into pyrolysis, you are going to produce electricity. If you burn it a little bit at a lower temperature, you're going to incinerate it, produce a lot of CO2, which is not good, but it's better than just leaving it in the air, and at least you will have some heat that you will be able to reuse, okay, in the location area of this plant. So that's already the first process that we see, which is today really well known and in practice in many countries around the world. Now we have two other processes which are linked to those domestical waste. The first one is the waste to hydrogen. That's a new process, completely new. I think we have 3 projects in the database about waste to hydrogen. They are really pilot, really demonstrator. And in this case, the idea is during the pyrolysis of those domestic waste, you are going to inject a lot of steam to a high temperature burning waste, about 4,000 degrees Celsius. And with this atmosphere of saturated steam and low oxygen, you are going to create a combination which on one side will make carbon. It will be mostly CO2 or CO, so monoxide of carbon, really harmful. But on the other side, you will also have hydrogen. And in this case, you can easily capture the hydrogen and separate, meaning that you can have a carbon capture unit taking the CO2 and the CO, and on the other side, some hydrogen production. There are, as I was saying, 3 projects in the database. They are testing the technology, but they are quite confident about it. And the first result from the pilot are quite convincing, to be honest. So maybe that will be something that we see more and more on the side of those waste to energy project. Maybe another unit of waste to hydrogen as well. It's concerned a lot. It will consume a lot of energy, but if you want to produce hydrogen, it's still on the energy side more efficient than producing green hydrogen from renewable electricity. And then the last application we see for the domestical waste, waste to fertilizer, because of course when you are going to burn all those trash and waste, of course at the bottom you will have in some cases some quality ash, and those ash can be mixed later on with some other product that can be produced like ammonia, etc., to later produce some efficient fertilizer, which will be sold and used by agriculturers for farms, etc. So that's also one way to reduce the carbon footprint and close a little bit this carbon loop that we were talking about. If we talk about bio-waste, it's a little bit a larger portfolio of opportunities, and this is why I put you on the left as the different sources that we consider as bio-waste. Bio-waste can be paper, can be wood, can be food, can be agriculture wasted, it can be restaurant food, it can be animal processing waste. And here in this case, we have 2 big families, if I may say. The first one is a thermal treatment, where you are going to by pyrolysis or by just heat, going to gasify your product and extract the carbon from there. But you are also able to make what we call the pre-fermentation, meaning keeping it as it is and let the deterioration effect happen in a closed environment. And that's the difference between the open environment. And there you will be able to collect biofuel, biogas, charcoal, syngas, synfuel, but also if you eat it a little bit, some SAF and sustainable aviation fuel. And this is today one of the main way to produce what we call clean fuel, etc. The idea of those fuel is that their carbon footprint is negative. So of course, if you mix it with existing fuel, especially for plane, you are able to have a plane which is net zero carbon fuel. Here I put you a slide that I will not comment, but I think it's a great resource. It's a slide from Roland Berger, where on the top you have the different type of bio feedstock, and you see it's quite a long list that you have. And here you see on the bottom all the operation that you can have to produce syngas, to produce lipids, to produce gas or jet fuel, etc. So it's also quite interesting to see that from this variability of feedstock, meaning that we can more or less reuse all those bio waste, you can produce different type of product which are energy interesting or which are interesting on the business was as well. Just a word about the supply chain itself of biofuel, of SAF or waste to recycling or waste to energy. Here I put you the example of SAF, Sustainable Aviation Fuel. Imagine that you are putting trash, your CO2 or your carbon, at least. The idea is to sort and to filter those things, those products, to process it a little bit, but then to transform. And it's what we call biorefineries, and it's a lot of revamp that we see as of today. And here it will enter the same loop as we have in the oil and gas. So the idea is to say, okay, by recycling those products, we are going to make some treatment upfront, but then we are going to be able to store it and blend it with existing fossil fuel for later on be used at the airport and to, of course, be fueled into a plane that will then be later burnt into the atmosphere. But the CO2 that will be emitted there will be less than the CO2 that was captured from the trash. So that's why this whole cycle and this whole value chain is, of course, beneficial for the environment. So what we need to understand is that we have to consider those projects as a side supply of raw material and raw carbon material. And today it's integrated and it starts to be mixed with existing existing asset, and the results are quite positive, to be honest. The quality in some cases can be questionable, but with the price of raw material going to the roof as of today, we know that we can add some treatment and pre-treatment to those to, of course, make sure that we have the right quality needed for our application. Going to the business-wise of those applications, if we look at the market as of today, here I put you the map of the different locations. In green, you have all the projects located worldwide. What is quite interesting, it's about 60 projects, a bit more than that, 65, I think, this morning. And you see it's quite located in some areas. Of course, some regions are quite in advance in terms of processes and financing for those projects, and because the US, Europe, and some let's say advanced Asiatic country want to be the first players and the first mover on those applications. So that's why you see those first hub, and that's also because that's where you have the need and the production of feedstock. Because if you want biofuel or if you want to recycle plastic, you need to have a source of plastic, you need to have the source of bio waste, and of course those three regions are the one with heavy population, with a lot of consumption of many materials, etc., etc. So that's why we see a lot of those projects happening there. But just so you have in mind, that's where that will be the three hubs as of we see today, and that's where the thing will develop more generically, meaning that US and Europe are really leading the game in those cases. If we look at the type of project behind, about 80% of those projects are small projects. It doesn't mean that they are pilot or demonstrator, because I was saying the technology are quite mature. The capex, average capex of those 80% project are about $100 million US, so it's quite big. But then, depending on let's say the application, it can be small or big. In the database, you will find biodiesel, bioethanol, SAF, waste to recycling, etc., which are quite big projects. If we look at the infrastructure for biogas is something which is really at a smaller scale. Usually it's at the size of a farm or a syndicate of farms. So you will not find so much biogas into our database because those projects are too small, and usually they don't have our definition of project because they are, let's say, local initiative. But if you talk about biofuel, bioethanol, biomethanol, there we go to larger scale. Those projects, they are done, those small-scale projects are done in 2-3 years, so quite quick. And of course, there are brownfield and revamp of existing facilities, especially biorefineries, because the refinery wants to be able to accept as feedstock crude oil, for example, but also some bioenergy, because it will reduce for a huge amount their carbon footprint, as well as being competitive on the price of the feedstock. From those 80%, we also have 20% of projects which are large. Okay, large meaning that the investment is above $1 billion US, and those will take a little bit more time. Of course, the complexity is a little bit different, and they will be done into 5-6 years. The project will be greenfield, of course, and the meaning of those projects is not to be located next to, let's say, the users of this energy, but just to export. And that's the case of a project, for example, we have in Paraguay, etc., where the goal of this project is to export energy as we could export oil and gas. What is also interesting with those projects is that most of them is private financing in comparison to green hydrogen or to renewable, where we see more and more private financing because those projects are getting profitable. Now, if you look at this project, they're always linked to a local opportunity, if I may say. Either the feedstock is there, so they're going to put the biorefinery here or the bio-treatment unit there. Either you have the user there, and that's the case, for example, of SAF, Sustainable Aviation Fuel, where you see most of those projects being linked to one airport. So, of course, as the production site is close to the airport. It's a growing tendency. It's really fast growing, and since mid of last year, it's just booming. Here you have the figures for waste to recycling. You have on the left the forecast on the top. So you see it started really in 2021 as a small pieces of about half a billion, but it's going to double more or less every year on what we see as of today. If it's going down after 2024, it doesn't mean that this market is going banana. It just reflects what we see of the market as of today. If you look what has been awarded also, EPC-wise, you see that most of this market has been already awarded, meaning that those projects are financed, and when they are financed, the independent company, and that's the figures you have on the right, mostly dominated by independent company. But those small operators are coming from the chemical industry or coming with licenses. And of course, they are the one making the engineering as well, the construction, etc., etc. So they have their all hand on all the project life cycle. So it's quite interesting because that's only one, let's say, one person you need to talk to be sure that your project or your product and equipment are well placed on the project. As I said, the life cycle is 2-3 years. So of course you need to be quick and you need to be upfront at the FEED stage if you want to be sure to get the order later on at the EPC stage. For SAF and biofuel, the situation is a little bit the same, even if we saw it, let's say, grow a little bit earlier. You see, we were starting to follow it in 2018, all those applications. But in 2021, when the calculation of carbon and the displacement of carbon footprint was created and was, let's say, accepted by the international community, of course, those projects took a huge momentum. And that's where the effect we see as of today in 21, you see the different stairs we are taking where it's completely ramping up. And for projects which are 2-3 years long, we see that here we have phase 1 development, but we already start to have those phase 2 behind, which are coming to, I say, fuel this pipeline until 2016. And of course, it would grow like crazy. You see what has been awarded. We are totally in this situation where the market will grow bigger and bigger to kind of exponential growth. Independent are also on the lead. It can be complete startups company. It can be also people originated from the chemical business, which are a little bit going upfront into the chemical. All those projects, and that's true for the waste recycling, but for the biofuel as well, the FEED contract is converted to EPC. Only few of them really, I would say, exception are going to an EPC bid, but most of them are conversion from FEED contract to EPC. And the most active players we see on this market are the mid-sized engineering companies. We don't see too much Technip, Saipem, those big boys, if I may say, although the American boys, we see mostly some niche expert on those applications. So it's also quite interesting to look after because the competition is way lower on those. Now, if we look, let's say, on a longer perspective, and here I will put two deadlines, 2030 and 2050. Of course, let's say, why those two deadlines? The first one, because the 10-year period is to say, okay, what will be done as of today, the action we see, and 2050 is, okay, what are the goals? Because most of the Paris agreements, etc., regarding the limitation of CO2 emission and greenhouse emission are linked to, let's say, deadline, which is in 2050. So if we look and start by the waste to recycling, and that's true for plastic, but that's true for all those polymer activities, you see on the left the global polymer demand. And that's something most of you are users of Project Smart Explorer. We had the chance to run and discuss this point during the workshop. But globally, the polymer demand is going to explode in ethylene, in polyethylene, in propylene, etc. All the plastic usage is going to explode. But the opposite, we are not able to produce so much more. So of course, and here you see it's quite a conservative figures, but you see in 2020 we are a bit around here. The right number is today we are about 500 million metric tons of polymer demand. So we are a little bit higher than this scenario, which for us is a bit conservative. But you see the explosion of need of polymer. And of course, the crude and the virgin ethylene will not be able to replace and to answer all this demand. So that's why this waste to recycling is going to take a huge momentum. And you see the figures here. You have plastic equivalent from mechanical recycling here on the top. Here you have the monomer recycling, and here it's plastic equivalent, meaning the recycling and chemical plastic used and received from the monomer. And you see that by 2050, it will represent about half of the market, which will source its raw material for plastic from those applications. So what does it mean in terms of number? Of course, here it means that the plastic will, or the recycling of plastic and polymers will become extremely profitable. and as it would represent 50% of the market, if we compare to today the plastic market, a reasonable estimation would be to say, okay, this part of plastic recycling will receive a yearly investment of $30 billion US. What is interesting with those applications, it's really close to the oil and gas, and they will come on top of the existing business, meaning it will not be one business replacing the others. When you see the volume of production which need to be achieved, it means that this business will grow on top of the existing one. So of course, if you have knowledge in those applications, if you have references, it means that your project will literally double just by the growth of this waste to recycling of plastic and chemicals. For chemicals, it's the exact same potential and the exact same figures. So it's really an interesting path. And you see that in 2030, it means that we'll grow about 50% compared to what we have as of today. So it means that in 10 years' time, this market can be around already 10 billion yearly. When you see the size of project, about 100 million, it means that it will be a tons of project and a tons of opportunity already. If we go to the SAF, which is a specific, let's say, a trend as of today, the Sustainable Aviation Fuel is, of course, taking off if we make a role play, because the goal of many, let's say, aviation companies is to say, okay, you can fly carbon-free. And of course, that's a huge competitive advantage. And if you are Boeing or if you are Airbus, you don't have many opportunities to decarbonate your industries because the electrical plane will never fly. It will be too heavy. And going hydrogen is a huge problematic because the density of hydrogen energy is too low, really, to have a flight crossing the Atlantic Ocean, etc., etc. Which means that the SAF is kind of technically the only possibility they have to decarbonate their industry. So if you look at the jet fuel today, it represents about 8% of the oil consumption. So it's about 8 million barrels per day, which is a huge volume. I would say today, let's say in a few years when COVID will have stopped, it will represent about 8 million barrels per day. So it's a huge volume. And of course, this volume of jet fuel is going to double in demand in the coming years. And on those next 30 years, the demand will go to at least 16 million barrels per day, which is huge, which is a huge volume. And what is happening with the SAF is that the SAF, when it produced, is so carbon negative that you can mix it with fossil fuel and still have a net zero jet fuel. So today, the ratio of this blend between SAF and jet fuel is about 3%. That's the figure we are going for 2025. But of course, this ratio needs to grow in order to first decarbonate the flight, but then to decarbonate all the life cycle of the flying industry and the plane industry, meaning that first you need to compensate the flight, then you need to compensate the operation of the plane on the ground, then to compensate the production of the plane, then to compensate all the life cycle of the plane, of the airport, etc., etc. So it means that this ratio is going to grow gradually. So of course, it means that for the SAF production, it will grow by two means. The volume of the total jet fuel is growing, so it means that the SAF will grow by the same amount, but the ratio of blend will grow so much that it means that the SAF is going, and that's the ratio for Europe, where we are today in this situation where we are going to have about 1 million, we expect, of barrel per day in 2025, and maybe it will go to 30 million, etc., equivalent, okay, of jet fuel. So it means that we will require a lot of SAF behind, and the investment and rolling investment on a yearly basis will be around 40 billion, which is a huge again, opportunity just for this application. Then, of course, SAF need to be transported, etc., etc. So it's a little bit more midstream as well than the other application. If I go to the biofuel, what is interesting for the biofuel industry today, those biofuels, they are really linked to the car industry, and the demand for biofuel will grow everywhere. Because we are talking a lot about electric cars, etc., etc. But imagine tomorrow if we are producing biofuel which are carbon negative. Of course, everybody will want to keep their car, keep the installation of the pump station, etc., etc. And by using your car, you will, let's say, decrease the carbon footprint of the world. So everybody will be happy to do it. And the estimation which has been made by the IEA is to say, okay, if the road transport turns to bio and synthetic fuel, it means that here you will see the growth of the biofuel demand, which is, of course, a huge growth. I mean, compared to 2025. As of today, we are really in this scenario, and to be honest. And of course, you see in 2050 how much it will represent. The main region for those biofuel would be China, here in light green, but you see here Europe and here North America, which would be the three leaders and the three hubs of those applications. So just by itself, biofuel to be used in trucks, to be used in, let's say, heavy transportation, etc., or just to be mixed to reduce the carbon footprint of refining activities, will represent for sure 30 billion, okay, every year of investment. So it's a huge business opportunity. But if we're in this scenario where the road transport is going to turn to bio and synthetic fuel, will be in another scale and another level where those biofuel projects, biodiesel, bioethanol, etc., will turn to a business of about 100 billion every year, which would be huge. Of course, today, the road transport is going a bit more into the direction of electricity. But let's see in a few years if we are not coming back. Germany is starting to go a little bit outside of this electric path for road transport. They are starting to have those programs of biofuel, etc., etc. So I think it has a meaning and is getting more and more momentum. Of course, because it means that you will not need to change your car, you will not need to change anything, to be honest, and you can have a clear impact on the carbon footprint of the whole road transport industry. Now we are going to a conclusion, and I see the time is running. The idea behind this application is that we are seeing an entire new market emerging. I would say the key driver for this revolution was to enable in the international community the calculation of this carbon footprint, where you could displace the carbon footprint from the decomposition of those carbon material into the reusage of it. So of course, those markets are trying to prove a little bit, are trying to find themselves and trying to develop the technology brick to scale up those activities. Once again, it's a scale up they are looking for, because most of the application waste to recycling are already known, but where those projects were into the size of, let's say, Comal, local communities, etc. Today, they are really going to the industrial mode into billions, etc. So they still need to adapt a little bit their technology to it. What is interesting is that the wave is starting right now, meaning the project and the first financement started pre-feed in, let's say, second half of 2021, which means that today we are starting those feed projects, etc., etc. So of course, it's quite important to go on board today, because if you are not on the feed, you will never be on the EPC and you will never build your reference list. What is also important on the long term is to see that the demand will steadily grow at a really high level till 2050 at least. Then we don't know where we are, but already in 2030 the market will be comparable to petrochem, because if you add all those layers in 2030 you will be around 50 billion already in terms of project on a yearly basis. So of course it would be a huge volume of opportunity. It will not be as big as petrochem, but it will be somewhere comparable to it, and it's a brand new business which is growing up. The opportunity for all the players of the oil and gas is, of course, to transfer your know-how on those applications, because it's super close to what we are actually doing. And of course, the idea is for you to reuse your equipment and reuse your know-how to serve those applications. And the last part, in which he is putting a lot of trust and confidence in those projects, is that the financing are coming from the public in financing, but also from the private, which is always a good sign when private companies are financing those projects, because you have a direct impact on the carbon footprint. You can really reduce the operation and let's say the running of the world with those applications, but also you can become profitable. And if you are not as of today profitable, you know that in 2-3 years you will be profitable. most of the break-even of those projects are calculated for comparable to the oil, to a barrel price, which will be around $75 per barrel, which means that today, in the situation that we are, of course, all those projects are highly profitable. So, of course, they are all launched to go after one another. As a conclusion, I would say that you have to be ready to jump in, because it's a formidable opportunity. And with Project Smart Explorer, we are putting a lot of effort to trace those projects. So, of course, we can help you to do so.